Okay, class, good morning. So now let's have the profile labeling sample problem. So from the given, this is profile. From the given profile labeling notes, compute the elevation at each points or each stations, and then you have the difference in elevation between the station 040 and the station 080. So from our previous topic, which is differential leveling, so you can just have the elevation of these two stations, subtract, so that you can have the difference of difference in elevation uh, for these stations, and then you will construct the profile of the ground. By the way, for the profile of the ground, you have the graphing paper. Okay, you have the graphing paper, and then you have here the elevation versus the station. Normally the station should have a 20 meter interval, and then the lowest elevation here is the lowest elevation in your data, or that is 0.1 meter below your smallest elevation in your data or in your table. And then you have the elevation and station, so therefore you can have this for station 20, station 40, station 60, and then up to how many station. And then you will draw, or you will connect the points using a freehand. Okay, using freehand, you will connect the points. So that's the profile of the ground. Okay, so that's how to construct the profile of the ground based from your tabulated data. You have the elevation and the station. Okay, so but before that, let's have the computation. So for the computation, you are given the stationing, and then the backside. You have backside for the benchmark 1, turning point 1, and turning point 2. And also you have the elevation of the benchmark. Usually that is the uh, benchmark, or that is assumed, or maybe that is the actual elevation of your benchmark 1. Then you have the intermediate foresight and the foresight of each turning points. Okay, so let's answer. So to recap, you have the formula for the height of instruments. Okay, height of instruments, HI, is equivalent to elevation plus backside. Okay, and then you have the elevation is equivalent to height of instrument minus foresight or intermediate foresight. Okay, so therefore let's answer this data. So you have first the height of instruments, this one. So that is 200 plus 1.285. Okay, so this is 201.285. Then next you have the elevation of station 20. Okay, so therefore to solve for the elevation, that is height of instrument minus the foresight. So you have minus 2.354. That is 198.94. Okay, and then no need to solve again for the height of instrument since you have the same, or you have only the stationing. If that's the turning point, you have another height of instrument here. Okay, so let's have the elevation of this one. So this one minus this one minus. Okay, so you have 201.285 minus 1.301. That is 199.984. Okay, and then 2.380. So 198.905. And then next station 80 is 1.789. That is 199.496. Then last station, that is the last station before the turning point, you have station 100. The intermediate foresight is 2.456. Is 198.829. And then you have the last foresight before the turning point. You have 0.764. Therefore minus 0.764. So you have 200.521. And then you have the turning point. So you have the turning point. So you now have the other height of instrument. The height of instrument is elevation plus the backside. So you have your elevation, which is 200.521 plus 2.314. Okay, so therefore that is 202.835. Okay, that is now your new height of instrument since you transfer your instrument to another station or to another area. So you have now your turning point 1. Okay, so you now have your another height. So next is you minus your, or subtract your intermediate foresight. Okay, and then this one. So you have 202.835 minus 0.897. That is 201.938. And then 2.987 is 199.994. 2.848, and then 2.314 is 200.521. Then you have 1.562 is 201.273. Then you have the foresight for your turning point, since maybe at this station to the next you cannot see it directly, so you move to another area, so you have now your turning point 2. Okay, so you have 202.835 minus 2.721. So you have your elevation of 200.114. So you transfer to another area, so you have now your backside for turning point 2. So you have now your new height of instrument. Okay, so the height of instrument now is 200.114 plus the backside of 0.865. This is 200.979. Okay, so that is now your new height of instrument for the turning point 2. Okay, and then you subtract the intermediate foresight. Okay, so subtract, you have 200.979 minus 0.895. So that is 200.084, and then 2.645, 198.334, and then last station is 2.314. It's 198.665. Okay, so that's the elevation of all the stations, and then you have the difference for elevation 40 and elevation 180. So elevation 180 is 201.273 minus elevation 40, that is 199.984. Therefore you have 201.273 minus 199.984. Okay, so the difference elevation is 1.289 meters. That's the answer. And then to construct the profile of the ground, you have the, as what I have discussed earlier, you have the lowest elevation of 198.334. So therefore you can have your stationing or the elevation here. You have 198 point, I think 2, and then 198.3, 198.4 up to 202. Okay, and then you have the station, so 0 plus 020 up to 0 plus 240. Okay, no need to have a turning point in your station, so disregard the turning points and also the benchmark, or you can have the disregard the benchmark and the turning points. Okay, for your profile of the ground, so start with 0 station, and then 0 plus 20 up to 0 plus 40. Okay, no need to have stationing of TP or turning points. Okay, and then you plot. So for station 20, that is 198.94. So maybe for this is station 20, so maybe somewhere here up to, and then you draw your profile of the ground. Okay, so that's it. Maybe I will have to have an assignment maybe for you to construct the profile of the ground for this problem. Okay, so that is all.